Okay, these are the Module 11 Part 4 notes. This is page 1. We are going to take a look at what we did in Mod 11 Part 3 and go backwards. So before, we had an X value, we had a height, we had an IQ, and we worked to figure out how it was related to the general population as a whole. Now we're going to take a look at a specific probability and see if we can backtrack and find the X value. So let's talk about how we do that. Here's my equation for finding the z-score. I had z equals x minus the mean all over the standard deviation. So we want to solve for x, which means I need to get x by itself. I'm going to go ahead and just solve for x. So I'm going to start by getting rid of the denominator. I'm going to multiply both sides by sigma. And so now I have sigma times z equals x minus mu. Again, this is what I'm trying to get by itself. So we're going to go ahead and add mu to both sides. And so my x equals, and I'm flipping sides here, sigma times z plus mu. You can either remember that equation, or if you're really comfortable with that equation for finding the z-score, you can just use that and solve for x as you need to. Okay. We're going to approach this the same way we did before. We're going to draw the curve. We're going to shade the approximate area. Remember that that middle, that median, is our 50% line. It doesn't matter if your shading is correct or incredibly precise. It just kind of gives us a visual of what we're looking for. So we want a normal curve here. I have a median of 0, a standard deviation of 1. We want the z-score where the area to the left is 0.0808. So I know that my one standard deviation, right, gives me an area to the left of 0.16. My two standard deviations gives me an area to the left of 0.0235. Not sure what happened there. So if I want a z-score where the area to the left is 0.0808, it's going to be somewhere between those two. Keep in mind this is not linear, so it's not halfway between. But I can just take a guess. And shade my area. And so we're going to look for work that's consistent with what we did in the last module. We want the normal curve labeled with the possible z-score location. You are going to get credit for doing that, not for how accurate that is. It's got to be on the correct side of the mean, you know, and it's got to look like there's a decent effort there. 2, we want the appropriate region shaded, so make sure you read specifically as to whether we're looking for the area to the left or to the right. We need the Excel commands, and we are going to look at those in a minute. And then we need the z-score rounded to the nearest hundred, so we want that to 2 decimal places. And so let's back up here a minute. When we used in Excel, When we used norm.dist, we took a z-score in, and what we got out was the probability. We need to go backwards, so that was norm.dist and norm.s.dist if we had straight z-score. Now we're going to use norm.inverse, norm.inv, or norm.s.inv. Which is probability in z or x out. And we'll be specific about which ones we use where in just a minute. So example 2, we want the z-score, so the area under the normal curve to the left is 0.75. So first things first, we know that the median is 50. We know that +1 standard deviation that should look a little more under that line. There we go. Gives us the 50 plus another 34. So we know that 0.75's got to be somewhere in the middle there. Again, doesn't have to be that specific. Here's my line. Here's my 0.75. There's my area under the curve to the left. Okay, so that's 1 and 2. So now we need the Excel command. Okay. So what we are going to plug in here, this is our standardized normal curve. We've got a mean of 0 and a standard deviation of 1. So same as before, we start with norm.s, that standardized curve. We're counting in terms of standard deviations. And again, we want the inverse. Norm.s.inverse. The only thing we need to plug in is the probability. So let me stick that down here. I got norm.s.inverse probability. When we plug that in, we get 0.67449. Again, we're looking up here to where it says the nearest hundredth, so 2 decimal places. So my z-score, this is giving me a z-score. 2 decimal places, I look at the one behind it, it's less than 5, so this stays as 0.67.